Hi, so we are now going to look at how we can come up with a series solution for this given differential equation. So the first step in being able to answer such questions is that we are supposed to remember or to realize that we can write our y, okay, our y to be equals to the summation from n is equals to 0, or starting from n, like n starting from 0 going as far as infinity, and that would be like our a sub n multiplied by x to the power n. So it simply means, for example, where I have y here, I'm going to substitute with everything that I have here. But we'll be like, wait, what about where we have our y prime as well as y prime prime? Okay, so what you can do right here is that you can just differentiate what you have here to suit what you're looking for. Okay, so it simply means I'll have to determine my y prime as well as my y prime prime. Okay, so y prime is simply the first derivative. Okay, our y prime is the first derivative. Which is going to be equals to, we are going to say the summation. Now, instead of me starting from n is equals to 0, I'll start from n is equals to 1. And you are going to see this in a short while. So this still remains to be our a sub n, but if or when you apply the power rule, you observe that this one, the power is going to drop and reduce by 1. That is the basic power rule. That's how we differentiate. So here, this is going to be like your n, then a sub n x to the power n minus 1. Okay, which is pretty interesting. Then I'll get my y prime prime, which is my second derivative, and this is going to be equals to the summation n now starting from 2. I no longer start from 0, and I no longer start from 1. So I'm still going as far as infinity. So now I still have my n, which is this n here. Then the power, which is this one, has dropped and reduced by 1. So when that happens, you have like your n minus 1. You have n minus 1, then you have your a sub n x to the power n minus 2. So what it is that if, for example, if I look at this one, if I maintain the fact that I start from 0, if I plug in 0 here, you're going to get there's nothing that you're going to get there. Okay, for the zero, for the 0th term, or like the first term which starts from 0. And the same thing applies here. If you put 0 here, everything will be 0. Same applies to if you plug in a 1 here, this will be 0, then everything else will be 0, and that's what I'm trying to avoid for now. Okay, so now I'm going to use everything that I have here and just substitute it in that, then see what I'm going to end up with. Okay, so now on the second derivative, which is my y prime prime, I'll say I'm just using I'm still going as far as infinity. Then you have your n is equals to 2. Okay, then that will be your n minus 1. Sorry, that is n open brackets n minus 1. Then you're going to still have your a sub n here, then that's your x to the power n minus 2. Okay, then that is for this part, that you have right here. Then for the other part, that would be like your minus 4x. Then you plug in your first derivative there, which is this one. That would be your n minus 1, then n multiplied by a sub n x n minus 1, like that. Then you do the same for this part here. You just write it the way it is, as you have your 4x squared minus 2. Then you plug in your y there, which is your you're starting from 0 for this one up to infinity. Then that's a sub n excuse me, a sub n multiplied by x to the power n is equals to 0. So what we need to do right here is that I observe that I have an x here, I have another x here when I expand that. So I need to do something about that. And what will happen is that this one, I'll still rewrite it the way it is. Okay, I'll still write it the way it is. I'll bring it down here. Okay, then here I'm going to have a 4. Okay, so I will still maintain the summation from n is equals to 1 to positive infinity. So for this part here, you observe that I had x here. Then what will happen is that I'm going to multiply this x by this x that I have here, and considering the fact that this x and this x are going to act as bases, meaning you can add the powers because the bases are the same, and this will just be like n a sub n, then that would be like x to the power n, because when you say x to the power 1 multiplied by x to the power n minus 1, this will be the powers. For the powers, it will be like 1 plus n minus 1, which is just going to be n. That's why I only have an n right here. Okay, so minus. So I'm going to have a 4 here, then the summation from n is equals to 0 to positive infinity. So I'll still have my a sub n, then that will be x to the power n plus 2. Where am I getting the n plus 2 from? It's because when I multiply this x and this x, the bases are the same, so add the powers. There's this 2 and there's this n. Okay, then minus, there's this 2 that you have right here, so that would be your 2. Then from n is equals to 0 to infinity, of course, by a sub n, then x to the power n is equals to 0. Okay, so we have kind of like dealt with the fact that we had these variables right here, so we have dealt with them, and we can go ahead and do the shifting. Okay, so what do I really mean when I say shifting? Okay, so let me just bring this up here like that. So when I say shifting the index, what I mean is this. I want to ensure that the power for this x, for this x, for this x, and for that x is the same. Okay, and in most cases we just write it to be x to the power 1, but the idea is just to make it the same. So if you're able to write it in such a way that it's not really n but it's the same, then it's okay. And again, we should ensure to say what you have here and what you have here, what you have here and what you have here is the same. What I'm trying to put across here is that you are supposed to start from the same point. Okay, so if this is starting from n is equals to 2, make sure this is starting from n is equals to 2, same for this one and same for that one. Okay, so what I can observe here is that this is already x to the power n and this is x to the power n, so I should just shift the index for this one and for that one there. Okay, so here's how this one is going to be. So that would be let me explain what this one is going to be. You are still going as far as infinity. So for me to make sure to say this becomes n, what I need to do is that where there is n, I'm going to substitute with n plus 2. So meaning this was like n minus 2, right? Then where there is n, I'm going to put n plus 2 so that I'm still subtracting the minus 2 there. It's still going to be minus 2, and this is going to be n like that. So it simply means anywhere here, anywhere where you see n, substitute with n plus 2. So if you put n plus 2 here, that would be like n plus 2 is equals to 2, which just ends up to be 0. Like it will be n is equals to 0, like that. So you're going to say n is equals to 0. Then you have like your n plus 2. Then for this part, when you substitute, that will be n plus 1, n plus 1, then this will be your a sub n plus 2, then x to the power n plus, okay, then that will be your 4. You still going to write it just the way it is. That is already to the power n there, still going up to infinity. That will be your n, a sub n, x to the n minus 4 summation. We are still going up to infinity. So what it is here is that for me to ensure to say this is n, since I'm shifting the index, I need, where there is n, I need to plug in n minus 2. So if I say n plus 2, then where there's n, I plug in n minus 2. That would be like n minus 2 plus 2 to give me n is equals to 0. Okay, so what you do here is that even where there's n is equals to 0, like where there's n here, just plug in with n minus 1 here, sorry, n minus 2. So you observe to say, if you say n minus 2 is equals to 0, like you can just take the 2 on the other side. So this would be like n is equals to positive 2. So you still have like your that would be your a here, then n minus 2, then that would be your x to the power n. Okay, that would be your x to the power x to the power n, then minus, you don't need shift to shift the last one, there's nothing there that needs shifting, so that would be n is equals to 0, then a sub n x to the n is equals to 0. So where we have reached now is it's pretty interesting. All we have to now ensure to say is that we observe to say this is n, that is n, that is n, and that is n, which is pretty good. So from here now you can just make sure to say all of these, they are starting from the same point, but from our observation, this is starting from 0, starting from 1, starting from 2, starting from 0. So all of them need to start from the same point for me to write it as a single polynomial kind of. Okay, so what you can do right here is that on this first term, okay, on the first term, you can evaluate for a term where n is equals to 0. Also evaluate for the term where n is equals to 1. What am I trying to do? Is because I can't reduce this one. It's kind of like hard for me to reduce it. So instead, I'm going to evaluate for each of these three such that they start from n is equals to 2. And that's why I'm saying for this part here, for the first one, where you're going to evaluate for n is equals to 0 and n is equals to what? N is equals to 1, so that you remain with n is equals to 2. That's the pattern. It's like you have like n starts from 0, 1, 2, 3. So if I evaluate for this one here, it simply means now my n is going to start from what? From 2, because I now know what the term where n is equals to 0 is, and I know what my term is when n is equals to 1. And you do the same for this one. You observe that for this one, you don't have to evaluate for n is equals to 0, because evaluate where the n is starting from. So this is like n is starting from 1, going to 2, to 3, to 4, so on and so forth. So if I evaluate for 1, meaning now my n will be starting from what? From 2, because I already know what my n is equals to 1 is when I substitute. And do the same for that one for n is equals to 0 and n is equals to 1. Okay, so for simplicity purposes, what I'm going to do is that I'll write for this one down here, and for that one. Okay, so here is how this is going to come out. So when n is equals to 0 for this one here, what you get, it simply means you just plug in 0 here, plug in 0 there, plug in 0, plug in 0. Anywhere where you see n, just plug in 0. And this is going to end up to be this will be like 2a sub 2. When I plug in 0 there, I just remain with a sub 2. Okay, like that. Then what if my n is equals to 1? Okay, what if my n is equals to 1? What do we get? So plug in 1 there, 1 there, 1 there, and 1 there. This is going to be something like that would be a 6, because I'm going to get a 3 and a 2 here. So when you multiply them, you get a 6. Then that would be like your a sub 3, then x to the power 1, which is just x. Okay, so come to this one now. When n is equals to 1, what do you get? What you get is that this is just going to be 4 a sub 1 of x. Okay, a sub 1 of x there, like that. And have I written the correct sign here? I think I have mistaken the sign. This is supposed to be negative. Then the other one is supposed to be positive. Yeah, sorry about that. So this is supposed to be minus from this one. Then I think this one is supposed to be positive. Actually, it's supposed to be positive. So we say plus there, like that. Okay, so meaning this one is going to be minus. So what about the last one? So for the last one, this would be like when you say n is equals to 0, what do you get? So what you get here is that you're going to get minus 2a sub 0. Okay, so what about when n is equals to 1? Okay, so this is going to be like I think this is going to be minus 2 um, minus 2, then a sub 1 to the power a sub 1 times x to the power 1. So just something like that. Okay, so having done that, here's how this is going to unfold. um, so sometimes it seems like it's too much of work to do, but yeah, if you just follow it step by step, you eventually arrive at the answer that you are looking for. So having subtracted the first and the zeroth term and the first and the, like, where n is equals to 0 and n is equals to 1 for that one, for that one as well as that one, what it now ends up to be is that I'm going to get everything that I have here. Okay, I'm going to get everything that I have right here. I'll just move it a bit up. But now what changes is that um, this will start from 2, this will also start from 2, this will also start from 2. Okay, so meaning this will be like n is equals to 2, n is equals to 2, and n is equals to 2 right here. Okay, which is what I wanted to do in the first place. So here, before I put in the equals to 0 here, for convenience's sake, I'm going to add, okay, I'll just write it right here. I'm going to add everything that I've done here. So it's like, for this part, I have like 2a, 2a sub 2 plus 6a sub 3x minus 4a sub 1x, then I'll say minus that would be minus 2a sub 0 minus 2a sub 1x. Okay, like that. So now this one now is what is going to be equals to 0. So it's like I'm adding everything here plus what? Plus what I have right here. Okay, so now how is this going to unfold? So you can try to simplify this one. You observe that I have x for on this part, x on that part, and x on that part there. Then for these ones, it doesn't have an x. So what I can do here is that, let me just focus on this one for now. Let me show you how it's going to be. So if I say 2a sub 2, then I place it with that one, which is minus 2a sub 0. Then for these that have x's, this is going to be plus 6a sub 3x. Okay, actually I can factor out the x, so meaning I can have like minus, so you observe to say this is minus 4 and minus 2 there. So since this is a sub 1 and a sub 1, they are like terms, you can add them. So that's going to be minus 6a sub 1. Then I can put x there like that. Okay, so I want to find what my a sub 2 is in terms of a sub 1. So you observe to say your a sub 2 is just nothing but this is equals to a sub 0. Okay, so and the same applies to this part here. Your a sub 3 will be equals to a sub 1. Okay, which make things a little interesting and much easier. So I'm just going to write them somewhere right here. I'll say a sub 2 is equals to a sub 0. Then your a sub 3 is equals to a sub 1. Okay, so now having done that, I'm just going to go ahead and write this as a single series, since they start from the same point and the power is the same for x. So this is going to be like summation, then that will be like your n is equals to 2, then infinity there like that. Then I'll put everything in these brackets. I'll say n plus 2, n plus 1, then that will be your a sub n plus 2. I'll not put this because more like it's more like I factored it out, so that will be minus 4 n a sub n plus 4 a sub n minus 2 minus 2 a sub n, like that. Then I can close, then that will be your x to the power n is equals to 0, like that. Okay, so this is what I have. So now you can determine your recurrence relation from what you have here. And how you determine the recurrence relation is that just um, make the a sub like that has the highest, like the highest a sub something, like I don't know, like this is bigger than this one. Why am I saying so? It's because it's bigger by what? By 2. This one is smaller by -2. This one is just end there like that. So make this one that is bigger the subject of the formula. That is what is going to give you the recurrence relation, and that's what actually that's what you need to come up with your series solution. Okay, so we just have to remember what we have here to say our a sub n I mean our a sub 2, our a sub 2 is equals to a sub 0, and our a sub 3 is equals to a sub 1. It's very important to remember that. We'll use that. So if you make that like this one the sub of the formula, like this would be something like your a sub n plus 2 is equals to, so everything here is more like it goes on the other side of the equal sign. So this would be like plus 4n a sub n minus 4 a sub n minus 2, then that would be plus 2a sub n divide by this one here, which is going to be your n plus 2 multiplied by n plus 1, like that. Okay, so this is what I have as my recurrence relation. So from this recurrence relation, now I can come up with I can evaluate for values, like let's say I'll start from n is equals to 2. I don't have to start from n is equals to 0, because if I set from n is equals to 0, meaning I have like a sub 2, and I already have my a sub 2, which is a sub 0. And again, I don't want to start from n is equals to 1. Why? What do I mean? If I put 1 here, this would be like a sub 3, but I already have my a sub 3 here. So it simply means I want to start from n is equals to 2. And that's a convenience of what I'm doing right here. So this is like, I'll start from n is equals to 2. Let me look at what I'm going to have. If I plug in 2 there, okay, if I plug in 2, this would be like a sub 4 is equals to, so here this would be like 4 multiplied by 2, then that would be a sub 2 minus 4 a sub 0. Why am I saying 0? When you plug in a 2 here, that would be 2 minus 2, giving you a 0, then plus 2 a sub 0 divide by that would be a 4 multiplied by 3. Okay, so what does this give us? So everything here, of course, this is going to be more like this would be 8 a sub 2, that would be minus 2 a sub 0. I've just evaluated for that part. Actually, this is supposed to be a sub 2, not a sub 0. Then divide by, I'll just say 12 here. Okay, so this would be like 8 a sub 2. Then I'll say I can actually add these two. I can actually add these two since they are the same. I can add this one and I can add that one. So which means I have like 10 a sub 2 minus 4 a sub 0 divided by 12. But I know that say my a sub I know that my a sub 2 is equals to a sub 0. So this would be like 12 a sub 0. I'm just quoting it from that part. A minus 4 a sub why am I getting the 12? This is supposed to be 10 actually. So this is 10 a sub 2 minus 4 sorry, it changes to a sub 0. So this is our 10 a sub 0 minus 4 a sub 0 divided by 12. This just ends up to be 6 a sub 0 divided by 12. Hence I can reduce this and say a sub 0 divided by 2, like that. Okay, so one thing that I've observed is that I'll just write it somewhere up here, that my a sub 4 is equals to a sub 0 divided by 2. That's what I've gotten. Let me now try to evaluate for the other n. Like I'll just be scaling up. Okay, I'll put 2 there like that. Actually, is this now going to be a 3? So now, if you plug in 3 there, that would be like your a sub 5 will be equals to. So this would be like 4 multiplied by 3. Then that would be your a sub 3 minus 4 a sub 1. Why am I getting the 1? I'm just saying 3 minus 2 to give me a 1 plus 2 a sub 3 divided by, that would be 3 plus 5 plus 2, that would be a 5 multiplied by 4. Multiplied by 4, that's for the denominator here. And if you evaluate this properly, and if you observe to say your a sub 3 can be substituted by a sub 1, it simply means your a sub 5 will be equals to, you're going to end up with something like a sub 1 over 2. That's what you're going to get if you evaluate this step by step. Okay, so let's look at what we can have when n is equals to 4. So when n is equals to 4, this would be like a sub 6. Okay, a sub 6 is equals to, you're going to say 4, then you say 4 here, then a sub 4 minus 4a sub 2 plus 2 a sub 4 divide by, that would be 6 multiplied by 5. And if you evaluate this step by step, your a sub 6 is just going to be equals to a sub 0 divided by 6, like that. So let me try out maybe the last step. I can continue with this, but I'll just call it the last step for now. So I'll say n is equals to 5. So meaning this would be like a sub 7 is equals to 4 times 5, then a sub 5 minus 4 a sub 3 plus 2 a sub 5 divide by, that would be 7 multiplied by 6. Okay, multiplied by 6. If you evaluate this step by step, you already have your a sub 5. So where you have where you have this here, you can substitute with that. Okay, then where you have this, the a sub 3, you can substitute with a sub 1. And you're going to observe that if you follow that step by step, your a sub 7 is just going to be equals to it will be equals to a sub 1 divided by 6. And one thing that I observe here is that if you continue this, the next one, instead of being 6, is going to be 24. Okay, so it simply means I can write this as a sub 0 divided by 2 factorial. This will be a sub 0 divided by that will be divided by another 2 factorial here. Then this will be like a sub 1. Wait a minute. This will be a sub 1 divided by 2 factorial. Then this will be a sub 0 divided by that would be what? That would be 3 factorial. That's what gives us a 6. Then this would be a sub 1 divided by 3 factorial, like that. Okay, so having done that, I can now make a conclusion. Okay, I can now make a conclusion to say my y, okay, my y, which is my solution, is just equals to starting with a sub 0 plus a sub 1x plus what follows is my a sub 0 by x squared divided by 2 factorial. Then I'll say plus a sub 1 times x squared divided by 2 factorial plus a sub 0 divided by 3 factorial multiplied by x to the power 3 plus a sub 1 divided by 3 factorial multiplied by x to the power 3 there, like that, plus, and it keeps on going like that. Hence you can simplify this to say you can factor out the a sub 0. So that would be like I'm going to say this is a sub 0 open bracket. I'll have like a 1 plus, I get this one that has a sub 0, that would be like plus x squared divided by 2 factorial plus, I get another one that has a sub 0, which is that one, that would be like x to the power 3 divided by 3 factorial plus, this continues like that. Then I'll say plus, I have an a sub 1. So a sub 1, now this one will not be 1 here, this will be x. plus, then here I'll say x to the power 2 divided by 2 factorial plus, that would be x to the power 3 divided by 3 factorial plus, and it keeps on going like that. And this is the solution that I was looking for this differential equation right here. And that's how you answer this one. Thank you very much for watching.